Hey guys. So, like I told you guys, next part's water. So the first part was a review of all the chemistry things: atoms, matter, covalent bonds, ionic bonds, all of that kind of stuff. And now we're going to come back and talk about water. Now, some of this you should already know from last year, but maybe not. So that's fine. So it's kind of review water. Water's real unique because even though water does share electrons, okay, it doesn't share them equally. So water is termed a polar covalent compound. Actually, I would use molecule. Okay, so it's a molecule that tends to be unequal in distribution of the electrons. So what happens is oxygen's pretty big, a lot bigger than hydrogen. And remember, I don't know if you guys remember from last year, but I always try to teach hydrogen's small. It always wants to be hooked up to something. Because if it's not, it's just a proton. And it doesn't want it to be just a proton. So it likes to be with something else. And so what happens here is because it's pulled, got a little positive on the hydrogen end and a little negative on the oxygen end. What can happen is that hydrogen bonds can form to another molecule of water. So this part over here with the hydrogen actually, because it's still it's positive, forms kind of a little bond right here. And then down here, we're going to see the oxygen of another molecule is going to be attack, going to make a bond. So we got these bonds constantly making, breaking, and these are called hydrogen bonds. Okay. So very weak electrical attraction between a positive charged hydrogen atom and a negatively partially charged negative atom of oxygen. Okay, so water pretty much is the polar covalent molecule. Now there's some others that do it. This is the main one. This is the only one we need to worry about. Okay, so here we can see here's the hydrogen bonds forming and breaking, forming and breaking. And you can kind of see here it gets a little technical about the degrees and all of that. And this is what's going to allow water to do the two things that it does. And I think you can remember what the two things: it likes itself, adhesive, no cohesive, and adhesive. It likes other things. I mean, like adhesive tape. So we'll get there. Okay. So here's two other words we got to kind of introduce here. Now, I think your book introduces these somewhere else, but we're going to go ahead and introduce the words water. So we're going to go ahead and introduce them now. Just to me, it makes sense to introduce them now. So if it's hydrophilic, it really likes water. Okay, so it loves water. So a hydrophilic surface. This is why when you pour water into a graduated cylinder flask, it likes the side. So you got to read the bottom of the dip, the meniscus, remember? But a hydrophobic surface allows for it to, doesn't like it and allows for it to be the opposite way. Okay. So hydrophilic, we love water. Hydrophobic, we don't like water. Water hating. Okay. So it repels water or attracts water. This is important because things that like water going to be hydrophilic, and there are some things that need to be hydrophilic because it needs to like water. But then there's some things in our bodies, like our cell membrane, needs to be a little hydrophobic because we don't want to dissolve. And we're going to get there again. We're going to see this again, these terms again and again, and along with water. Okay. Um, so life supporting properties of water. So in a living cell, water runs from anywhere from 75% to 85%. So again, when I tell you guys we're just big bags of water with some chemicals, this is true. Okay. Check out the infographic on page 55. 2.2 got lots of good stuff there. So we talk about water. Water's big thing because it is got these bonds breaking and forming. Uh, it is what we call the universal solvent, meaning that it dissolves just about anything. Okay, that's why you wash your clothes in water. Um, and I say just about anything because you know there are some things it doesn't. That's why you have to put detergent in there, and that's why you have to put stuff on some of your stains. And in some of your stains, you got to take to the dry cleaner because they're the only ones that can get it out. Okay, so we got a solvent and a solute makes up a solution. Okay, so when we look at a solvent, it does the dissolving. Any substance in which another substance is dissolved, it does the dissolving. Solute is the dissolved substance, and these two things make up a solution. Okay, now a solvent, when we talk about solutions, we're going to talk about solutions being like how much solvent do you have and how much solute do you have. Well, if you have 10 grams or 10% or whatever of a solute, then you got 90% or 90 grams of water. Okay, because these two plus each other has got to be 100. Okay, because you can't have more than 100%. Okay, you can have more than 100 grams in something, but you can't have more than 100% of that in there. Okay, and we'll talk about this as we go through. And I think in physical science, you talked about saturated solutions and supersaturated solutions and those kind of things. We're not necessarily going to get too much into that. An aqueous solution means that it's dissolved in water. That water is a solvent. So most of the things that we're dealing with are aqueous solutions. Okay, everything's going to be dissolved in water or going to be able to be dissolved in water. Okay, so one of the big properties of water. The two other properties of water we just talked about, its cohesive property, okay, in that it is attracted to, holds molecules of the same substance together. Water likes itself. It's cohesive. Okay, likes itself. This allows for that to form a surface tension. That's why critters can walk on water. When Jesus walked on water, he didn't break the hydrogen bonds. And when Peter jumped out of the boat, he didn't break the hydrogen bonds until he looked down, and then he broke them. Okay, so to cohesive, water likes itself. Okay, because water likes itself, it takes a lot to get it to break. Okay, and that's that heat capacity one. So a lot of energy has got to get in it in order to break those hydrogen bonds between the water molecules for the temperature to go up. Okay, so if a body of water changes temperature more than a degree or two, something's going on. There's some heat being added into that somewhere, someplace. Okay, so those are some things to think about. Now, heat of vaporization is the amount of heat that it gets a liquid to go to a gas. And one of the cool things about heat of vaporization is that, and heat capacity is one of the cool things is when the water molecules do leave as a vapor, it takes the heat with it. So which means that body of water now cools down. That's why when we sweat, it's a good thing because it cools our body down. So essentially, in order to maintain homeostasis, we're just using a water property for us as we sweat. Okay. The other property of water is adhesive, and water likes other things. Water likes the surfaces of other things. It likes tubes, capillary action, and other substances. So it's cohesive, likes itself. It's adhesive. Think of adhesive tape sticking to other things. It's adhesive. Okay. Um, the last thing here we're going to talk about is the density of ice. So the thing about water is, as it freezes top down. So it loses energy from the top of it, and those molecules freeze, and it freezes top down. Also, water, the ice is less dense, and so it floats on top of water, okay, on top of the liquid. This is the only one that does it. Everything else, when it freezes, it expands, and when it gets hot, it contracts. Water doesn't. Water expands when it's cold and freezes. When it freezes, it contracts. And anyway, we'll show you here in just a second. Here we go. So cohesive water molecules are attracted to each other. Okay, so this allows molecules to stick together to make oceans, rivers, the water in your glass. Cohesive allows the surface tension. So you see that a little paper clips on top. We're gonna do this in lab the beginning of week 3. Okay, so we're gonna deal with water. I think the beginning of week 3, and then we deal with pH. That second lab in this module. Okay. Um, Adhesive means that water is attracted to other substances. This is capillary action. This means that water from the ground can go up to the top of the leaves in these huge, gigantic redwood trees. Okay, so pretty neat. Goes against gravity. So water will go up a tube against gravity. Uh oh, something's going on. Okay, so that's trying to go to that site. I got. If you want to see where the different sites, you can click on the different images. So on your own, we're gonna again in class we're gonna go over a lot more examples, and we're gonna deal with water. So describe the structure of a water molecule and explain how the structure results in attraction. So it likes itself, sticks together. Okay, cohesive. It likes other things, sticks to other stuff, likes other things. So this allows for it to be one of that universal solvent we talked about. Okay, give an example of how the cohesive properties among water molecules are important to living things, bodies of water, um, being the surface tension, the heat of vaporization, the heat of fusion, high heat capacity, all of that is the cohesiveness. Okay, so one way water can moderate temperature is that, like we said, it takes a lot of energy to get it to change the temperature. But one of the cool things is when that water molecule leaves, it takes the heat with it, and it cools down that body of water. Okay, or your body, kind of cool. Okay, guys, so let me go. Let me look at the picture we got here. So here's the adhesive properties, but here's the universal solvent stuff. And we didn't, there's some other terms that we kind of need to mention. If it's polar, it means it's attracted to water. So polar molecules are hydrophilic, it likes water, but non-polar substances are like fats, lipids, and they don't mix with water. So that's why, and you can see this here. And I think you guys did last year where you did the density column. That's pretty cool too. So I think you guys are looked at that. The high specific heat again, because it has that high specific heat, water doesn't bodies of water doesn't they don't have a experience a lot of temperature flux. That's why at the ocean at night you get this nice sea breeze happening. Okay, um, because of the high specific heat, during the daytime that heat's taken away, that body of water cools. Now the air flows back to the land and it's a lot cooler. Now this is also lake effect snow and big bodies of water. Okay, Lake Nantahala is not big enough to give us lake effect snow, but it'd be pretty cool if it did, if for all of us that like snow. This high heat capacity allows us to keep our body temperature constant outside. Again, to main we sweat, and that's why we can talk about sweating is very important to us because as we sweat, it takes the heat away. So that's why you want to sweat when you're hot. You don't want to sweat too much when you're hot because then you're losing water, so you got to put your water back in. And if you don't sweat, then you got to get your body temperature down. Okay, so you can have heat exhaustion and heat prostration. So very important things that we sweat. Okay, the density again we talked about. Water is less dense, so it floats on top. Okay, so pretty neat stuff with water. Hopefully, we made a lot of sense. If not, we're going to do the lab in class and do some cool things with water that you probably haven't done before. Okay, so thank you again for watching. This one's about water. I think the next one is we start the carbon chemistry. Okay, the biochemistry, what's life, the life chemistry. All right, thank you.